I am here today with a very cursed programming problem that I can't solve, that maybe someone in the internet has an idea on how to solve, but I already tried everything I can think of, no solution. I have this function here that adds two floats and then multiplies with 35. Right here you can see when it adds the 35 is right here, then it multiplies by 35 by acquiring the value from RAM, multiplying, doing a NOP, and then returning. The problem that I have with this is that I don't want to load the 35 from RAM. Instead of loading the 35 from RAM, I wanted to just generate it in code like this, with an immediate load and then an empty C1. Now, I will show you a few attempts I have at solving this, and I will show you how I technically solved this, but if I solve it the way I did, I will run into a GCC compiler bug that lets me not actually use it, because it breaks the rest of the program. This in total would save one instruction, and it would reduce one D-cache access, so we save around half a microsecond maybe per every float multiplication, which, you know, that's pretty relevant for the N64, and 4 bytes of memory, which is like, who cares. Alright, my first attempt at solving this. I declare a float 35, I cast the float to a U32 pointer, which is just unsigned int. I set it to 420C0000, which is just 35 in float representation. I tried to multiply it. GCC says no. GCC looks through that and says nope, don't get that. Alright, second. This is a failed attempt because it just converts this really large number into floating point representation, so we can't use that. Attempt number 3. Now we're getting a bit crazier. We're defining a union of a float and an int. And we set the int literal to 420C, then we read the value. Unfortunately, GCC sees right through our bullshit. It knows, hey, that's just a fucking float you're loading. I'm gonna load it from RAM, fuck you. Not good. Alright, let's get even more creative. We just set the int to 420C, we cast the int to a floating pointer, we load from the pointer, and GCC can tell, he can see right through our bullshit. Doesn't work. Okay, I got 2 more tricks. 3 more tricks actually. Let's inline a load float function that takes a float pointer and a literal value, and then we just call this function with a pointer to our float and the 420C, and unfortunately GCC sees right through that. It also doesn't work. Now, I have one more idea. Things are getting a bit ridiculous here. We have a U8 array of 4 elements, and we set it to 420C, 0 and 0, and we mem copy over our float on the stack our 4 bytes in the array, and then we'll multiply with the thing we just mem copied over. And unfortunately, GCC sees right through this. So what else can we do? How can we solve this? There's a solution. Like I said, there's a solution, but it bugs on GCC and you can't actually use it in the program. And that is, we inline our assembly function here. Shoutouts to Wiseguy for making this. And our inline assembly function generates the floating point load. Beautiful, we have it, right? You see, you have the multiplication with the float here. We call our inline assembly. And right here you can see it's in the code now. We did it, but there's a problem. If you inline assembly in a function, it breaks floating point comparisons in the rest of the program for MIPS GCC. So, for example, if you look at my proof 1 and proof 2 here, proof 1 uses the bad 1 function with no inline assembly. Proof 2 uses the good function with inline assembly. You look at the comparison of the proof. It's a c.lt.s, a NOP, and a bc1t, which the NOP is necessary because if you don't have a NOP, the result of the comparison is not going to be available and the result is going to be undefined. And unfortunately, the NOP is missing here because GCC bugs out. I'm out of ideas. There's nothing I can do. If someone on the internet has a better idea on how to potentially solve this that doesn't break GCC, which means no inline assembly, I will be very happy. Also, just for fun, a slightly better method on doing this would be with an inline assembly, more without NOP, and then the beta function here. You can see, already gets pretty close to perfect. It did not swap around these two here, which kind of really sucks, and actually that will break the program because the JR has a delay slot afterwards, so now it's just gonna execute the floating point value here as if it was an instruction, so I guess that's also a MIPS GCC bug. But yeah, if anyone has an idea, let me know in a comment. I will attach this document here in the comments as well, so you can take a look at it and try for yourself with all my compiler flags, which is, wow, a lot. That's it. See ya.